A 16 milliliter sample of oxygen is collected over water at 15 degrees Celsius. The atmospheric pressure is 732 torr. What volume would the dry gas occupy at 720 torr and 22 degrees Celsius? And we are given that the partial pressure of water at 15 degrees Celsius is 12.8 torr. So this is a combined gas law question, so we are going to use P1V1 over T1 equals P2V2 over T2. However, we have to remember that anytime a sample of gas is collected over water, part of the pressure in that sample of gas is because of water. So we have to apply this second little formula. The total pressure is equal to the sum of all the gases in the sample. So here our sample is made up of oxygen, and we have some water vapor that's escaped into that sample of oxygen. So the total pressure is going to be equivalent to the atmospheric pressure. So you can kind of just plug that in right there. And then we're looking to find this guy. We want to know the pressure contributed from just the oxygen gas. So that's where we're going to use this constant 12.8 for water at 15 degrees Celsius. And you can simply subtract that from the total pressure, and this will tell you the pressure that the oxygen contributed to this scenario. So when you do that, you should get 719.2 torr. So that is the pressure from just the oxygen gas. Alright, so now that we know that piece of information, let's label our variables. So my starting pressure of my oxygen gas is that 719.2. The volume of my sample is 16 milliliters, and this all happens at a temperature of 15 degrees Celsius, but let's change that to Kelvin, so add 273, so we get 288. And then the conditions I want to modify here is I want to see what happens to the volume if I change the pressure to 720 torr. Which that's not much. There's not much of a change going here. So what does that do to the volume? And we're going to change the temperature just slightly as well. So we're going to go to 22 degrees Celsius. If you add 273 to that, you end up with 295 Kelvin. Okay, so I'm going to rearrange that formula just a little bit so we can solve just for V2. So we end up with P1 V1 times T2 over T1 times P2. And then you just plug all your happy little numbers in. So 719.2 times 16 times 288, all divided by 720 times 295, and of course we're using parentheses and brackets where necessary, and our calculator is going to tell us that this should affect the volume and make it 15.6. Not changing the temperature too much, the pressure's not changing very much. We would also not expect the volume to be too far from its initial value of 16. So 15.6 milliliters.